We're going to get started. I'll start off slowly so people can still join. But essentially, we are SolCold. We're here today I'm here today to introduce our product, show you some of our use cases, explain to you the technology, the physics behind the technology, and show you how to install it. We're keen to keep it quick and fun and engaging. So any questions, any comments, feel free to put them in. And we're getting started right now. So we are SolCold. We are based in Israel, in the city of Rehovot. We have about 25 employees full-time here, comprised of physicists, thermodynamic engineers, chemists, and business as well. We have essentially developed a product. It's a thin film that I'm holding in my hand, a little sample of it, in the form of a sticker. It's a coating that can be applied to any external building, and as long as it is directly under the sun, it will cool that object that it is attached to. The material itself is combined of 4 different main components. In these components, as I said, is a very thin film. But what we're essentially doing is we are reflecting 98.5% of all UV solar radiation. And then we're actually allowing 1.5% of that to get through. So that first percent is hitting our anti-Stokes layer, which is converting the heat into light. I'll expand on that in a next slide. And then another 0.5% is going onto the radiative cooling layer, which is releasing the excess heat. And then on the bottom layer, we have a mirror layer, which is basically everything that's gone through the material is now being bounced back up and it's going to space. Here on the material, my sample, you can actually see the mirror layer, and that is the underside of the coating. What this allows us to do is to achieve -5 degrees Celsius below ambient temperature, which is 12.6 degrees Fahrenheit. For the sake of simplicity, I will stick to Celsius as I discuss the material and its applications and the results, but in the slides, you'll have the Fahrenheit here. This is the film itself. It comes in a form of a white roll. So it is going to be 50 meters long and 60 centimeters wide. So it's just a long roll that you can cut easily with a Stanley knife and cut it to any size and apply it to your object. How it works. So essentially, like I mentioned, we have those 4 layers. Firstly, we are reflecting 98.5% of all solar and UV heat and radiation. So, well, most materials will actually turn the light into heat. So it's gonna, absorb heat and absorb light being turned into heat. And so then we're actually doing the opposite with our anti-Stokes mechanism. We're essentially absorbing that sunlight, and then we're also absorbing the surface heat that it's created, and using them together, we're converting them both into a higher energy light. So that is basically we're slowing down the molecules or speeding them up into a specific frequency. And then that is emitted away using our highway to outer space, which is radiative cooling. Essentially, the atmosphere, as you can see here at the bottom, allows in all different types of waves. So we have gamma rays all the way up to long waves. So most of the heat that's coming in is in the visible and infrared spectrum. And there's something called an atmospheric window. An atmospheric window is where heat can pass through the atmosphere on its way back out without it being caught in the atmosphere. So that's why we get a greenhouse gas effect, because most of our all the wavelengths that are emitted from Earth are being caught in the atmosphere. And we are able to use this atmospheric window, which is actually a wavelength between 8 to 14 microns on the long wave infrared spectrum. So that's right around here. And like you see here, we're basically shooting it right into space Sometimes you can send also radio waves into space without it being interfered or getting caught up in the atmosphere. Essentially, what that's doing is taking all that heat that we have absorbed, created the cooling, and then sending it straight back up to space, where it's not going to contribute to any more urban heat island effects. What that means in practicality. So comparing to other surfaces, we have ambient temperature. Let's say example, the ambient temperature is a 35-degree Celsius day, very hot, a regularly hot day in the summer. So your aluminium sheet can absorb 15 degrees Celsius on top of that, can reach 50 degrees, maybe even more. It'll be very hot to the touch. Once you apply the SolCold to that sheet, we will be 5 degrees Celsius below ambient temperature. So we're going to keep it at a cool 30 degrees in the summer instead of the 50 that would have gotten. So that's a 20 degrees. We're also 12 degrees colder than white paint. We all know white paint is the coldest color. If you live in a hot country, you want your car to be white versus a black car because that's just going to get a lot more hot. But even white paint will absorb a lot of solar radiation, especially on the infrared spectrum. And so we're going to be 12 degrees cooler than the white paint. Not to mention steel, which is getting 35 degrees Celsius above ambient. So that's going to reach 70. And we can keep that steel tanker silo or electronic box at again, a cool 30 degrees versus the 70 that it would have gotten. So that's a 40-degree reduction. What that means for a value proposition for SolCold, on almost all the projects that we've done that have a cooling system, we have a 30 to 60-degree reduction on energy, which is a huge energy savings, both financially, environmentally, and obviously will just make your energy systems more efficient, reduce the maintenance, increase the longevity of them. There's no operating costs. So once you apply it, it's fully passive. You stick it on once, forget about it, good to go, and it will do that job without being connected to anything else. It will enhance the resilience and the productivity. So any heat-sensitive assets and infrastructure, whether it's your battery storage systems or food that you're storing, we will increase the lifespan of that and protect it. It's a carbon negative product. Essentially, you can claim carbon credits on it due to the energy reduction of the cooling systems. And a big question that's always asked is the 10-year expected lifespan. So this will hold and cool actively for those 10 years, probably even more. But as we are a startup, our tests have only allowed us to go as 10 years, but that's a number that we can confidently state and stand by. Again, if you have any questions, please throw them in the comments. I'll be able to read them as I go along. Some of the projects we've done worldwide, we've got in the logistics sector, tanks and silos in food and beverage, and chemicals, petrochemicals, utilities, piping, containers, buildings, warehouses, telecommunication, and electronic boxes. And you can't see the word here, but it says textile. We even have a textile version of our material. And I'll also show some case studies for that. So like I mentioned, all the industries that we are applicable for, and these are some of the clients we have across the globe. Some large brand names, AB InBev, I'll show you their project in a second. Volkswagen, we're actually going to be putting our material into their skylight of their future car of, I think, 2027. Coca-Cola, in multiple countries, we've got different projects. Bentley, I've also got the case study to show you. Amazon, we're doing in Spain right now on large warehouses. Grupo Mexico, a mining company, we've got a project in Arizona with them. ICL is the Dead Sea company in Israel. We've got multiple projects with them, and Capital Land in Singapore. This is a project with AB InBev in Brazil. So we coated their left silo and in the year 2023. And what we saw as soon as we coated it was a 31% reduction in cooling on their power consumption. Additionally, we increased their yield by 0.5%. So the alcohol concentrate inside the steeping silo of the beer manufacturing process was stronger, so they essentially had to use less alcohol to create their end product. And importantly, we also reduced the days that exceeded 26 degrees Celsius by a third every year. They had a payback of under 1 year. And speaking as we speak, we have contractors on the roof of the second silo being coated as we speak, which will be done by the end of this month, if I'm not mistaken. So that's very exciting. You'll see next meeting, next webinar, you'll have both these silos coated. This is a wine silo in Israel with a winery called Dalton. Again, we coated one silo, the other one next to it uncoated. These are made out of steel, polished steel. And what we saw was that we reduced any sort of evaporation, reduced their cooling costs. We reduced temperature by 15 degrees Celsius from the uncoated to coated on a 32 Celsius day. I'm seeing your questions. I'm going to start answering them once I get through my case studies. Just keep shooting them there as you have them. This is with ICL, the Israel Electric Company. We coated a server room similar to a data center. We saw also a 30% lower power consumption, 6 degrees Celsius inside, and 6,000 tons reduced of CO2 emissions just from the energy reduction. And they also had a payback of 3 years. We're doing now many more projects with the IEC. And this was a very successful project. It's here in Israel. If anyone comes and visits, I'm sure I can take you here and we can see it. Your standard shipping container, 20 foot. So this shipping container is actually being used for a battery recycling company, also in Israel, called BRI. They could actually install a smaller AC unit inside the container, because for the employees that are doing their recycling inside there. And we saw a 26 degree reduction inside the container from when we coated it. You can see in the graphs a clear drop in reduction just from applying our sticker in the sun. It was even September, just after the main peak of summer. It looks good. The temperature reduction was great, and they are very, very happy. Electronic enclosures, a huge market for us, which we're very interested in helping also to increase the longevity of the sensitive equipment that's being stored inside them, whether it's batteries or just your regular transformers and wires and sensors, systems, things like that. So we see, rule of thumb, around 12 degrees Celsius. We're cooling internally inside the electronic enclosures. And we've actually partnered up with a distributor of these electronic enclosures, and they're able to sell an end product of a cold electronic enclosure box. So if that's something of interest, welcome to reach out. We have the data for these, and very promising results. Also, this is with the IEC that I mentioned, the Israeli Electric Company, and now we're going for a full-scale rollout with them on that. Modular data centers and BESS battery energy storage systems. So just from cooling the enclosures of like the rooftop of these systems and of these modular containers by 15 degrees Celsius, we can extend the lifespan, reduce HVAC system workloads, and essentially just giving them a lot more efficiency, reduce their energy costs, reduce the water usage that they use for cooling, making them more sustainable, protect the equipment, increase their sustainability. And we all know how much energy data centers are going to be using in the next decade at least. So we're here to help reduce those costs. It can either be retrofit or put on in the planning stages. This is a large logistics warehouse, 2,000 square meters we did here in Israel. As you can see, I'm going to do quickly into the details, but essentially before the coating, the roof, the SolCold roof, is the red lines in the graph here, and our reference building, which is a building the same equivalent size in the same area next door, was actually 2 degrees colder due to a bit more airflow they had, and even got up to 5 degrees colder. But we decided we're going to coat the hotter warehouse, and you can see the temperature of the baseline. After we coated it, we actually reduced the roof surface temperature by 25 degrees. So now the roof surface temperature got to a nice cold 35 degrees Celsius or 40. This is in the middle of July. But more interestingly was inside the central room temperature. So we had sensors both on the roof and inside the warehouse. So before the coating, both the room temperature and the reference room were above ambient. The SolCold room was 7 degrees above ambient, and the reference, like I mentioned, was colder than the SolCold, and that was 4 degrees above ambient. Once we coated the SolCold roof, it's got to below ambient temperatures, so 4 to 5 degrees on average below ambient. So on days that we're reaching 38 degrees even, and inside we're keeping it at a cool 32. So um, the workers that would work inside these warehouses who were driving the forklifts used to call this the SolCold, the pre-SolCold warehouse, the hot unbearable warehouse, and now it's the cold warehouse. So just from their feeling itself is much more comfortable to work in, and yeah, they're able to get the sub-ambient temperatures on those hot days in the summer. You can't even put a price tag on that. Not to mention all of the stuff that they're actually storing inside the logistics warehouse. Now we're increasing the lifespan of whatever foods um, or um, things that they had stored in there. It's just a confidential project, so I can't disclaim any more details on what was going on in there. Building roof example, chiller system. So this project is actually in Singapore. What we did, it's with a capital land, and we're able to put our SolCold material around their chiller system. When we put our SolCold material around the chiller system, the air intake that's being sucked into their chiller systems is up to 4 degrees Celsius cooler. And then because it is cooler, so then the system itself has to work less hard to cool such hot air because the air is now cooler. We're also putting it around the solar panels to increase albedo and give it a higher output. And for their piping, both water and air, to also improve the compressor workload. So this project is still ongoing. We don't have final results for it yet. These numbers are based off our initial simulation, and so far it looks looking very promising. So by the end of this summer, we'll have the results for that. For bifacial PV panel, also very relevant due to, like I mentioned, our high albedo. So bifacial panel, not only is it receiving sunlight from the top of the panel and generating electricity, it also allows sunlight to go through the panel, as seen in the picture here, bounces off the floor of the rooftop or the surface that it's hold onto, and then that sunlight that's being reflected is then being absorbed on the underside of the panel. That underside of the panel usually equates to about 10% of overall efficiency of the panel. Even that 10%, on large scale will mean a lot in terms of added energy output. With our material, we can increase that by 3x. So we're essentially turning that 3%, that 10%, we're making that 3 times better than it would have without our material due to our near 100% albedo. So we're increasing the total solar panel efficiency by 21%. And then obviously, if you coat the batteries and inverters, like I mentioned, we can increase the lifespan by 25% of both of those. So silos and tanks for oil and gas, just a quick example. We can reduce volatility, reduce evaporation, making the area safe, not letting it go to exceeding temperatures, and the volatilization of said stored petrochemicals and gas. This was a model that we've simulated, and we saw the temperature reduction of 40 degrees inside the silo, airflow reduction by a factor of 3, and all in all, just created a much more stable environment for the storage of these chemicals and petrochemicals gas. Textiles. We're missing a slide here. Okay, well, we also have a textile version of our material. As you can see, it is can be applied to tents, to car coverings, to apparel, gazebos, shade structures, you name it. The beauty of this textile material is it is also based off the same concepts with our anti-Stokes and radiative cooling. It is elastic, it's stretchy, it's washable. It can be sewn onto any existing fabric, or it can be sewn onto itself, creating a large shade-like structure. What we saw was our tent with the material versus the tent without the material was 10 degrees difference in Celsius, which makes a huge difference. And then for Bentley, we did a car cover because their luxurious cars need to stay cool in the summer. So they actually tested us SolCold with a white other fabric, a black fabric, and then ambient. And then we saw the SolCold material was sticking just about below ambient and reduced 16 degrees temperature internally. Our latest product is our ice veil. It's a mesh material. It can be applied to windows. It is a semi-transparent, see-through material. So we've basically taken our sticker material, we've perforated very tiny holes, enough that you can see through, but not enough where the heat and solar radiation will come into the room. We see this to be about a 10 degrees reduction Celsius on the window itself, but the amount of solar radiation that will come into the room is huge. We're reducing all of that heat load that would essentially come in. So this could be used for commercial windows, sunroofs, transparent covers, outdoor equipment, airport jet bridge windows, you name it. And then as you can see here in the picture, the camera is blurring it up a little bit, but it's 100% transparent. You can see right through it the same way you could see through a fly net, for example. So we have 4 products. I'll just briefly go over them. Essentially, we have our Glacier 110, which is our flagship product. It is our premium cooling film, which can achieve up to 5 degrees Celsius below ambient temperature with a cooling power of 170 watts per square meter. It comes in the form of a film or a roll, like I mentioned. It has the self-adhesive, and that's used most for the server room containers, electronic enclosures, anything that's too heat sensitive, where every degree of Celsius makes a huge difference. And then we have our Polar 90, which is our economical or value cooling film, which can achieve up to 3.7 degrees Celsius below ambient temperature. That has a cooling power of 90 watts per square meter. Also, same properties as the Glacier, but this is used for more of the warehouses, large rooftops, large footprint sites, where every dollar or ROI is more important than every degree, but you're still getting that sub-ambient cooling. A Glacier X is the textile, as I mentioned, that has a sewn integration used for gazebos and shade structures. And then our Ice Veil, which is in a pilot stage. So that also has a 90 watt per square meter for the semi-transparent film. Currently, we're able to produce sheets the size of 50 by 50 centimeters for each square, and that can be increased, and that will be increased by Q2 of 2026. So we're looking at a few months from now to get to that commercial level. But we do have pilots available for this. Our international distribution network. So SolCold has partnered up with nearly a dozen distributors across the globe. Every single country that you see here, we have a representative in. They will be able to walk you through the technology. They'll be able to come and meet you for a demonstration or send you over material if you need. They are our local representatives, and they have the ability to distribute and install and maintain our product to the standard that we adhere to. So if you are in any of these countries, feel free to reach out through us at SolCold, and we will put you in contact with your local distributor. And if you're in a country that we don't have a distributor and you are interested in being one for us and you have the right connections and capabilities, we would love to do a partnership with you. So the bottom line, SolCold is the best performing cooling by sunlight technology, so we can hit that 170 watts per square meter of cooling, active cooling power. Our clients are multi-Fortune 500 customers, but we will sell to anyone who's willing to pay. Fast payback time. So we do hope to get an ROI between 7 months and up to 3 years. So that's a quick payback. We want you to get a return on your investment, whether it's by reducing the cooling costs on your AC, increasing the lifespan, increasing longevity of those items that we've coated. And we're here for the global impact of reducing the CO2 emissions, like we mentioned, the carbon credits, reducing the heat island effect, and making the world a colder place. We've got multiple first prize winners in international startup competitions. We go to trade shows across the world. You can see all of this information on our website. And that was it. So thank you for that quick presentation. Now I'm going to go through the questions. First question, can you elaborate on one of the Coca-Cola projects? So we do still have a confidentiality agreement with Coca-Cola. I can say that we've applied it on one of their vending machines and had a successful project with them where we had reduced their energy consumption of the vending machines quite nicely. And now we're in the talks with another Coca-Cola facility in a different country to coat their concentrate silos and warehouses. What is the application at Capital and Singapore? That's that roof that I showed you that was still in the pilot stage. Installation references in tropical countries, please. Okay, well, we have one in Nigeria, if I'm not mistaken, in a tropical country. What we have found is when the weather is more humid, more cloudy, more tropical, our material is still cooling. Now, it probably won't achieve the -5 degrees Celsius below ambient like we expect when it's a clear sky, but it will be the coldest material available to touch anywhere in that area. So while it's humid, we do still have that cooling power, probably at the -2, -3 degrees Celsius below ambient. Next question from Thomas Vergani. Congratulations for the presentation. Does it require any specific skill to install the material in industrial projects, or does it require any specific tool? Great question. So the material itself is a very simple adhesive film. I've installed multiple projects myself. The only thing that's required for a commercial in industrial projects is that there's a worker permit. There's height permits. You adhere to any safety regulations and safety standards for working on heights. The only tool that you need is a Stanley knife, a measuring tape, and maybe a soft glove to apply it. I'm gonna personally show you after I've answered these questions how to install it on this large sheet behind me. What about maritime applications, oil platforms, for example? Is there a reduction on the life expectancy? So most of the time, let me read that again. Any specific skill? Maritime. So it will work on oil platforms. It can work. I'm not going to tell you to put it underwater. That's not going to do anything. But if you had a storage container on a oil rig, for example, it would react just the same way. Any water would wash right off it. We don't market ourselves as a waterproofing material, but water doesn't penetrate the material. Does the cooling effect depend on weather conditions like humidity, clouds, etc.? I answered that. The cooling effect does get affected, but we will always stay the coldest material that there is. I didn't manage to follow all the case studies. How is SolCold working with real estate developers? Material used also on vertical walls. So Amit, this is something we can discuss additionally afterwards in private, but essentially we are working with real estate developers to help them achieve their LEED certificates, helping them get more LEED points on their green buildings. So also due to the high albedo, we can reduce the urban heat island effect. We can increase reduce the workload of their chiller systems, or in the planning stages, actually install a smaller chiller system on the rooftop. Can it be used on vertical walls? It can. We'd have to be in close contact with the manufacturer of the the facade developers and make sure we have the right adhesion and the right material to apply it on. Our material works best to be applied onto smooth and metallic structures. When it comes to applying it onto concrete or bitumen or anything like that, that has a bit more of a grainy texture and less smooth, we need to apply a nice primer before we apply our material, and then we can apply our material. So that does increase costs by a little bit. It increases the manpower to do something like that, but it is possible. With humidity, will the adhesion go bad? Not that we are aware of. So once it's applied, it has a strong adhesion to the surface, and there's no reason it should um, get unadhesed or get unstuck. Either way, we do have a PU glue, a special type of glue that gets put on the corners of our material to create that extra layer. Warranty indication, good question. We offer a 2-year warranty on the product with an option to purchase a 4-year warranty. And if there's a proper, we do have the option to work in partnership with our distributors where they can offer a maintenance package where essentially they can come, wash the material once a year, put any more PU glue on areas that's needed, and then that can extend the warranty as well once you have that package built in. Storage guidelines, as long as you're storing the material and it's not being used in the sun in a cool, dry area, that's fine. Installation on undulated surface is not easy. Correct. It isn't easy. That's why I mentioned we'll have to put a primer on. Mining site office where summer temp is around 45 degrees Celsius and winter is around 15. What temperature in winter will temperature be around 10 degrees? So in the winter, we are cooling, but we're not as cold as we are in the summer. So the hotter it is, the colder our material. So in the winter, you're probably expecting us to get to about 13 degrees Celsius, whereas in the summer, we can keep that rooftop, instead of going to 70 degrees Celsius, we'll keep it at the 40 degrees Celsius, maybe even lower. Okay, if there's no more questions, I'm going to quickly show you guys how to install it. I'll give it another second. Okay. Next, here we go for installation. So this video is available on our website. Essentially, the installation tools that you need is brush, gloves, and then a knife. You clean the surface and then dry it quickly. Very simple to just with a pressure washer for large scale. You can measure it on site. Doesn't have to be as exact because you can always cut it once it's been applied as well. Then you have a laser level, also optional. And then 2 people works best. 1 person holds it at the right angle. Another person goes with the sticker. We're taking away the liner in the back and applying it with the waves of the corrugated surface. There's a slight overlap between layers, 1 to 2 degrees Celsius. I will add a link to the video implementation, no problem. And this is also on our website under products. You can find the installation video. So once you have all that, you should be able to be a professional SolCold installer. This is another installation that I did 2 months ago. It was a pre-cut piece on an electronic box. Essentially, I'm removing the liner slowly, as I work my way down with a soft glove and just applying a sticker with no bubbles, no folds, a very clean installation right there. Okay, Mr. Emo217, please send me an email to discuss further. We'd love to chat. That was it. Oh, well, go back here. For any questions, like I mentioned, you can email me. Let me show you how to install it. We still have 20 people online and a few more minutes to share. So I've got a piece of material here with me. So I've taken a pre-cut piece. That's our sticker right there. It came off this roll. So I just unrolled it, cut it off. And what is it I'm going to do here is right behind me on this nice metallic surface. I'm going to peel off the liner. I've already rolled up that piece, but it's all the way over here. So once I've peeled it up, I can line up the material, apply it nice and carefully on the surface. And once I've done that, my piece can go down. And then using the glove, which is a soft kind of lets me slide across the material easily. I'm just going to go side to side, just like that. I'm applying the material right now, and this is going to last for that 10 years. It's going to cool you in the summer, and it's going to keep things real nice and cold. And that's it. That's how you install the material. Simple as that. Okay, Mr. Imo, you have a question about opportunities of channel partner distribution for India? Yes, please send me an email at ariel.wallace@solcold.com. I'm going to share my PowerPoint slide again. You can write down my email. It's also in the description of the video. And we can discuss partnership and distributor channels in India with pleasure. Do you see my email there? Mr. Alok, how much of rainfall can it handle? It's not a problem with rainfall. We can keep, it can withhold in the rainfall through the rainfall season. And then once the summer comes out, we'll be back to cooling again. Any way to reglue? Yep, you can reglue it with our PU glue that we put in the box with the purchase of the product, or you can even just use a regular silicone gun or anything like that. The installation video is attached here on our SolCold website. Just scroll down underneath those projects there, and you have the video of how to install it. I'll stay online a few more minutes if there's any other questions. Thank you everyone who joined, who engaged. You're welcome. Thank you, guys. Degradation on the cooling effect. A year, no. What we expect is after 10 years, our degradation will go down by about 10%, whereas solar panels are going down about 25% after those 10 years. So yeah, we're not expecting a large degradation. Wind effects. The only thing a wind would affect it is the cooling that we're generated is going to be blown away to another area. So for example, we're trying to cool the air surrounding the chiller system on the top of a building, and then you have strong winds. That cooling that we've generated, that cold air, might not go into the chiller system, and it will affect the overall cooling. That's the only thing that I can assume. Thank you, guys. Toda rabah, you're welcome. Take care, everyone. And again, please email me for any more questions. Thank you all so much for joining. And we're looking forward to having you next time. My pleasure, Alok. Make sure to send me an email. Thank you, guys. Thank you, Amit.